this over the course of the number of years I've taught this course. Some people start doing this triangle with that, and they put an M and a V and a D somewhere. If you want to do that because that's how you learn in science class and you're comfortable, I'm fine with it. All right. I just use the formula, though. I'm a formula guy, so that's what I'm going to be using. Density equals mass. The M is mass, V for volume. Also, here's what I need from you. Is when reading it, because these are all going to be word problems here on out. When reading a word problem, it is very rare that I will put the word density next to the number and say, hey, this is the density. I need you guys to identify, oh, that number is the density, and this is how you do it. Remember, density is mass over volume. So if I put 5 grams per centimeters cubed, we got to recognize I'm giving you the density. How? Mass, grams, over volume. And how do I know that's volume? It's cubed. Right, that's how we leave all our answers. It's cubed. So I need you guys to start recognizing, oh, he's giving me the density because I have mass over volume. All right, so let's start today identifying, oh, that's the density, even though he didn't write the word density. Okay? Why do I have all these conversions here? Starting tomorrow, we are going to have to convert units, but not today. So live it up today and understand density as much as you can, because tomorrow we're going to start converting units. So that's why you see all these conversions here. All good? Ready to hop into our first density question. Before I do that, though, we got a little predicament now in our hands because I am not checking any homework. So technically, no assignment for Mr. Promethean person to come up twice, or for you to guess, or if the answer comes up and I call on your number and it's the same answer. So here's what I'm going to do in return. I still want to make it exciting, right? We still got to talk about it. That's been like our thing all year, especially you guys. So what I'll do is if it does come up or if the number comes up and whatever, we have to guess the next slide, and you do get it. All right, I'm not going to cancel homework because I'm not checking anything anyway. I'm just going to pick something in my room randomly to give away to a random number. Okay, so that's what we're going to do. Somebody will walk out of here with something random. Okay, we can discuss what it is. I have no idea off the top of my head until it happens. So, all right, that's what we're going to do going forward. All right, here we go. Let's hop into a little density right now. Still got to make the class interesting. Just can't cancel the rest of the year on May 20th. We got a wooden cube, edge length 6 centimeters. You guys can see how much it weighs. What's the density to the nearest thousandth? And we got a little something extra to do at the end. So this is just straight up, what is the density using the formula? And if you guys want to use that triangle, that's fine. I have no idea how that bad boy works, but I'm going to use the formula. Density equals mass over volume. We're solving for density. We substitute in the mass, which is given to us in grams, 137.8 grams. And you will find out very quickly, all these problems I give you, oh, we're missing the volume. That's why we've done all this work for the last 3 or 4 days. You guys know how to find the volume of any figure I throw in front of you. This happens to be a cube. All right, this happens to be the cube, which is also a prism, right? So if, you don't have to write this step, but if you wanted to, you go to the formula sheet. I got to use BH, right? Got to use BH. How? Now, what is the volume? How are you calculating the volume? How is the volume being calculated? Here we go. Let's start it off right here. Gabby, how are you calculating the volume? Good. The base is 6 by 6 with the height of 6. So that's where all 3 of those come from. And we have a volume, it looks like, of 216 cubic centimeters. So there's my volume that I now substitute into the density formula. And notice the rounding directions are nearest thousandth. Ooh, first time I've asked that in a couple, ever maybe. 3 numbers after the decimal, everybody. Let me know what you have. Nearest thousandth. Zoe, when you're ready. Beautiful. All right, let's talk now because I'm a stickler for units. Unit 11 and 12. What would be the units on this density? Remember, density is mass over volume. So it's just not one unit I should see. I should see the mass, which was in grams, divided by the density, which was centimeter, or divided by the volume, which was centimeters cubed. So that's how I label a density. Oh, we got a second part to this, don't we, kids? What type of wood do I have here? So using the table real quickly, where am I here? There we go. Using the table, everyone can clearly see that we are dealing with some ash. Do I have any wood experts in the house? Like I could literally just go out, any tree, chop a hunk off, throw it right on the middle of your desk right now, and you maybe sniff it, look at it, touch it, whatever, and you could tell me what type of wood it is? Nobody?
I think I could get a good enough guess.
Out of all these here, you could tell me which one it would be?
Maybe.
What would you have to do? Sniff it? Look at the rings?
I mean, maybe taste.
Taste it? Yeah, you are with that. Yeah, yeah. Maybe a little hand soap on the side, right? No. Okay, any questions here? We're good? You guys are unbelievable. Unbelievable. All right, moving on. I'm only going to do the first three with you, by the way. The rest are your call. All right, the rest is up to you for the notes. Oh, a little shipping container. Right rectangular prism. Yeah, great. We see the dimensions. Hey, when it's completely filled, it weighs 0.25 pounds per cubic foot. All right, stop right there. I mentioned this 5 minutes ago. What's 0.25 pounds per cubic inch? That's your what here? Pounds per cubic inch. That's your density. I'm not going to put the word there. We got to recognize it. Again, how do you know that's the density? Because, ready, look at the units attached to it. Pounds, which is mass, per cubic foot, which is your volume. So that automatically tells me that's my D value. And what's the weight of the container? So it looks like we're looking for the mass now. So D equals mass divided by volume. We just said it's 0.25. Substitute that in for D. We're looking for how heavy the shipping container is. And I warned you guys last problem. We're going to have to find the volume on a lot of these. Hey, it's a right rectangular prism. So BH, according to my formula sheet. How are you finding the volume here? How are you finding the volume? Where are we going? Josh, how are you finding the volume?
Base times
Which would be?
48 times 8.
Yep, 12 times 4. And then we're doing times 8, or it doesn't really matter in any order. Good. So it looks like my volume would be a 408. What are we doing? Cubic feet. Substitute it in for V into your density. And it'll tell me how heavy this weighs. What is the weight of this container here? Not a big container, huh? Not a big container, Ksenia. Why? How much does it weigh? 102. Can we talk units now? All right. Oh, no. You relax. I'll do the teaching. Thanks. Always look back at your density. Always look back at your density. The density was 0.25 pounds. So that's what my answer is going to be in. For you kids on the street, that's LBs. All right. That's the street lingo. Questions? All right, one more. I love this problem. Yep, we're going back to trees. A American white oak. I don't know. Are there other different types of white oak, Josh, that I don't know about? I guess our Canadian white oak, maybe.
Sounds about right.
Okay. Nope. 752. All right. Well, I came out and gave you density. I told you there, but in case you didn't know, it's kilograms per cubic meter, mass and volume. Ooh, something a little different is going to happen here when I find the weight. So I still go back to mass over volume, plug in 752 for D. Finding the mass of this American white oak tree. Ooh, you ready for the volume? There's two things that are happening when we go find the volume of this American white oak. Number one is, I can give you the shape of it. Right? Which one of those figures on the formula sheet am I talking about? If we are talking about a white oak tree, all these polyhedrons we've gone through, which one do you think we're talking? A tree. Tree, everybody. Tree. Did I actually have to put the word in the problem? Or are we good? A tree. Well, let's find out. Oh boy. What figure am I talking about that resembles the tree? Well, thank you. Cylinder. This is a cylinder. So now I go to my formula sheet. volume of the cylinder, pi r squared times the height. That was only half the problem, is figuring out what figure I'm doing. The other problem is after I substitute in 8 for height, I notice right away that there is no radius given. I guess that's on us. Well, we do know the circumference, though. And remember, that's on the formula sheet as well. Circumference is on the formula sheet. How can I use the circumference to get to the radius? I know your formula sheet probably says 2 pi r, and I know that has radius in it, but I'm going to stay consistent with what I've been doing with you guys all year and using pi d. Plugging in 4.5 for the circumference, and somebody's going to help me solve for d now. What do I need to do on both sides here to solve for d? Ooh, Haley, what do you got?
Divide by pi.
Divide by pi. Good. I'm glad she didn't say, hey, pi's cancel out. There's no pi on the 4.5. They don't cancel out in this case. So now I got to divide it. You got two options. Leave your answer in terms of pi or write out the full decimal. I always write out the full decimal just because I don't have the answer in terms of pi. Shade over 1 meter for the diameter. All right, remember that's only the diameter. You guys got to plug in radius, so make sure you divide that beast by 2. Have some self-respect. And there it is. Or if you have it in terms of pi, don't forget to square it in the volume formula. Don't forget to square it. Still not, even when you find the volume, still not ready to round. So I'm keeping it in terms of pi or writing it all out. And substituting that one in for the mass. It does say approximate. Let's just go nearest whole number here. Nearest kilogram. Nearest kilogram, please. Nearest whole number. And you'll see this is one heavy tree. One heavy tree. In kilograms, how heavy is this tree? Olivia?
9,691.
Wow. And this is in kilograms. I know we usually don't work in this system of weights, but if you want to know pounds, that's about 21,000 pounds, kids. 10.5 tons. If you want to get even more detailed. It's a lot of weight for the tree. All right, any questions, comments, concerns? The rest is up to you. You're going to get out your Chromebooks, get the answer key out. Again, it's all detailed. All my work is there. What I multiply and divide by. Live it up now. Have a good grasp on this, please, because tomorrow we start changing units and have to convert. I don't care who you work with, move around. Let's get this done right now. You got plenty of time to finish it. It's just the rest of the notes. That's all it is. The rest of the density notes. That's all you're working on.